Good morning, students. So, this is a lecture on, in continuation on unit number 3, which was on introduction to solar energy, and this is in continuation to that. And this is a lecture on application of solar energy, and which is one of the important concept of solar cooker. The prerequisite knowledge here will include the solar energy harvesting, the concept of solar cells, and the solar energy applications. So these are some of the prerequisite or recapitulation knowledge which we must have to bring this course forward. In this slides, in this lecture, the main objectives of today's lecture is all about on 6 different aspects. Number 1 is history. Number 2, working principles. Number 3, operation. Number 4, box and panel designs. Number 5, parabolic reflectors. In that, we'll study about paraboloidal reflectors, parabolic troughs, spherical reflectors, vacuum tube technology, etc. And number 6 is all about on advantages and disadvantages. That's these are some of the objectives that will be done in today's lecture. Introduction, we can say that solar cooker is a device which will use the energy of direct sunlight to heat, cook, or pasteurize drink and other food materials. And many solar cookers currently in use are relatively inexpensive. They are low-tech devices, and although some of them are as powerful or as expensive as traditional stoves, and advanced large-scale solar cookers can cook for hundreds of people because they use no fuel and cost nothing to operate. So many non-profit organizations are promoting their use worldwide in order to help reduce fuel cost and air pollution and to help slow down deforestation and desertification. So the first academic description of the principle of a solar cooker is by the Swiss geologist, meteorologist, physicist, mountaineer, and alpine explorer Horace Benedict de Saussure in 1767. And the principle of cooking meals from the sun was largely developed in the French Foreign Legion in the 1870s. So this was a bit of history behind the solar cooker. So now talking about the working principle of the solar cooker. So number 1 is the concentrating sunlight. A mirrored surface with high specular reflection will be used to concentrate light from the sun into a very small cooking area. So depending upon the geometry of the surface, sunlight could be concentrated by several orders of magnitude, producing temperatures high enough to melt salt and metal. For most household, solar cooking applications such as high temperatures are not really required. So solar cooking products are typically designed to achieve temperatures of 65 degrees Celsius to 400 degrees Celsius on a sunny day. So number second is converting light energy to heat energy. So solar cookers concentrate sunlight onto a receiver, and the receiver can be such as a cooking pan. The interaction between the light energy and the receiver material converts light to heat and is called as a conduction. So this conversion is maximized by using some materials that will conduct and retain the heat. So pots and pans used on solar cookers should be matte black in color to maximize the absorption. That's where the principle of conduction and absorption comes into the picture. So third is trapping the heat energy. It is important to reduce convection by isolating the air inside the cooker from the air outside the cooker. Convection, the mode of heat transfer in liquids. Simply using a glass lid on your pot enhances the light absorption from the top of the pan and provides a greenhouse effect that will improve. Coming to the operation part, different kinds of solar cookers, maybe more than 300 models of a solar cooker had been made so far, and they use somewhat different methods of cooking, but most of them follow the same basic principles. That is, the food will be prepared as if for an oven or a stove top. However, because food cooks faster when it is in smaller pieces, food placed inside a solar cooker is usually cut into smaller pieces than it might otherwise be. For example, potatoes are usually cut into bite-sized pieces rather than roasted whole. For very simple cooking, such as melting butter or cheese, a lid may not be needed and the food may be placed on an uncovered tray or in a bowl. So if several foods are to be cooked separately, then they are placed in different containers. And the container of the food is placed inside the solar cooker, which may be elevated on a brick, rock, metal rivet, or other heat sink. And the solar cooker will be placed in direct sunlight. So foods that cook quickly may be added to the solar cooker later on. So rice for a midday meal might be started early in the morning with vegetables, cheese or soup added to the solar cooker in the middle of the morning. So depending on the size of the solar cooker and the number and quantity of cooked foods, a family may use one or more solar cookers. So a solar oven is turned towards the sun and left until the food is cooked. Unlike cooking on a stove or over a fire, which may require more than an hour of constant supervision, food in a solar oven is generally not stirred or turned over, both because it is unnecessary and because opening the solar oven allows the trapped heat to escape and thereby slows the cooking process. So if wanted, the solar oven may also be checked every 1 to 2 hours to turn the oven to face the sun more precisely and to ensure that shadows from nearby buildings or plants have not blocked the sunlight. And if the food So next is the box and the panel designs, in which the first one is the box cooker. So a box cooker has a transparent glass or a plastic top, and it also have additional reflectors. So what is the purpose of reflectors? It is to concentrate the sunlight, maximum sunlight into the box. The top can usually be removed to allow the dark pots containing food to be placed inside, and then one or more reflectors will be positioned to bounce the extra light into the interior of the oven. Then the cooking containers and the inside bottom of the cooker should be dark colored or black, and inside walls should be reflective to reduce the radiative heat loss and bounce the light towards the pots and the dark bottom, which is in direct contact with the pots. And the box should also have insulated sides. Thermal insulation for the solar box cooker must be able to withstand the temperature up to 150 degrees Celsius, or in Fahrenheit, if we say, that is 300-degree Fahrenheit, without melting or outgassing. So crumpled newspaper, wool racks, dry grass, sheets of cardboard, they can be used to insulate the walls of the cooker. So metal pots or bottom trays can be darkened either with a flat black spray paint, black tempera paint, or soot from a fire. The solar box cooker typically reaches a temperature of 150. This is not as hot as a standard oven, but still hot enough to cook food over a somewhat longer period of time. So solar oven science experiments are regularly done as projects in some of the high schools and some of the colleges across the globe, such as the solar oven throwdown at the University of Arizona. So these projects proved that it is possible to both achieve high temperatures as well as predict the high temperatures using some mathematical models. So next is parabolic reflectors. So parabolic solar cookers concentrate sunlight to a single point, and when this point is focused on the bottom of a pot, it can heat the pot quickly to very high temperatures, which can often be comparable with the temperatures achieved in gas and charcoal grills. And these type of solar cookers are widely used in several regions of the world, mostly in India and China, where hundreds of thousands of families use parabolic solar cookers for preparing food and heating water. And some parabolic solar cooker projects in China abate between 1 to 4 tons of carbon dioxide per year and receive carbon credits through the Clean Development Mechanism and Gold Standard. And some parabolic solar cookers incorporate cutting edge materials and designs which may lead to solar energy efficiencies greater than 90%. And others are large enough to feed thousands of people each day, such as a solar bowl at Auroville in India, which makes two meals per day for 1,000 people. So you can see a solar oven made of cardboard, newspapers, and reflective tape, and the solar tea kettle in one of the place where the tea is being prepared by the use of solar energy. So in vacuum tube technology, essentially the evacuated tube solar cookers are essentially a vacuum sealed between two layers of glass. And the vacuum allows the tube to act both as a super greenhouse as well as an insulator also. So the central cooking tube is made from borosilicate glass, which will be resistant to thermal shock, and it also has a vacuum beneath the surface to insulate the interior. So the inside of the tube will be linked with copper, stainless steel, and aluminum nitrile to better absorb and conduct heat from the sun's rays. Now, talking about the advantages and disadvantages. First, the advantages. High performance parabolic solar cookers and vacuum tube cookers can attain temperatures above 290 degrees Celsius. So they can be used to grill the meats, stir fry vegetables, make soup, bake bread, and boil water in minutes. The vacuum tube type cookers can heat up even in the clouds and freezing cold. The conventional solar box cookers attain the temperature up to 165 degrees Celsius. They can sterilize the water to prepare most foods that can be made in a conventional oven or stove, including bread, vegetables, and meat over a period of hours. Solar cookers, use no fuel, so which is a very good advantage. So this will save cost as well as reduce the environmental damage caused by fuel use. Since 2.5 billion people cook on open fires using biomass fuels, solar cookers could have large economic and environmental benefits by reducing the deforestation. So it reduces your carbon footprint by cooking without the use of carbon-based fuels or grid electricity from traditional sources. So some of the disadvantages include, so solar cookers are less useful at night or in cloudy weather and near the poles where the sun is low in the sky. So an alternative cooking source is still required in these conditions. So where there is no availability of sun, maybe at night or at cloudy weather, or when the sun is low in the sky, so the solar cookers are less effective, or they are less useful in these climatic conditions. So then solar cooking advocates suggest three devices for an integrated cooking solution. One is a solar cooker, a fuel efficient cook stove, an insulated storage container such as a basket filled with straw to store heated food. So some solar cookers, especially solar ovens, take a longer to cook food than a conventional stove or oven. Using solar cookers may require food preparation start hours before the meal. So cooks may need to learn special cooking techniques also to fry some common foods such as flatbreads like chapatis or tortillas. So panel solar cookers are inexpensive solar cookers that use reflective panels to direct sunlight to a cooking pot that is enclosed in a clear plastic bag. And as we told you, the solar cooker is an application where it uses the energy of sunlight to heat, cook, or pasteurize the drink and other food materials. And many solar cookers, they are very little expense, they are relatively inexpensive, and they are very powerful as traditional stoves, and advanced large scale solar cookers can cook for hundreds and hundreds of people. So these are references from where you can have the deeper insight on solar cooker technology. So these are some of the questions for you to answer. That is, what is solar cooker? What are the types of solar cooker? And what are the advantages of solar cooker over other alternatives? So these are the three questions that needs to be answered. So thank you for your time and attention.